Welcome back to Plasma Pro Tips, a series crafted to boost your skills with ICP-OES and ICP-MS systems with short, practical advice. As a reminder, each month we'll tackle a common issue with your sample introduction system. If you've got a question you'd like the Plasma Professor to answer, just leave a message in our online suggestion box. Now let's dive in. Take it away, Plasma Professor.
Thank you and welcome back, everyone. Plasma Professor here, and today we're focusing on the material of your ICP-MS cones. For most ICP-MS instruments, you may have several cone options to choose from. Today I will summarize the characteristics of each cone material so that you can use these as general guidelines to select the best cone for your application and analysis goals. Before we go too far, I want to quickly introduce this excellent ICP-MS cone resource guide, organized by the Glass Expansion team. You can scan the QR code or visit the Glass Expansion website to download your own copy. This resource guide covers today's topic on cone selection based on material, but also offers much more, including selection guidance by instrument model, cross-referencing OEM product numbers, and helpful tips on care and maintenance. As an ICP-MS analyst, you have a variety of cone materials to choose from, along with different combinations of these materials. Each has its pros and cons. Solid copper is often the most affordable option, which could benefit labs on a budget running low sample volumes and infrequent analyses. It can also be used for low-level measurements of aluminum, nickel, and platinum. However, in addition to cost, you must also consider performance and lifetime when choosing a cone. Since copper has the most efficient heat transfer compared to other cone materials, it runs colder, which also makes it the most susceptible to matrix effects, corrosion, and sample deposition, leading to a shorter lifetime, more frequent cone orifice clogging or blockage, and increased background from sample deposits. Since copper is more vulnerable to sample buildup, these cones will require more frequent cleaning. More frequent cleaning periods result in the ICP-MS being idle longer without running samples. This is an important factor to keep in mind for high-volume testing labs. Next up, we have nickel, which is commonly the standard choice because of its balance between cost and performance. With nickel, there are several combinations of materials to choose from. This can include a solid nickel tip with a copper base, a solid nickel tip and base, or a solid nickel tip with a nickel-plated copper base, which I will explain in more detail shortly. Nickel is suitable for most common ICP-MS applications, including routine aqueous environmental samples with a total acid matrix of 5% or less. If your sample matrix contains any percentage of hydrofluoric acid or volatile organic solvents, you should not use nickel cones. A nickel tip with a copper base offers good thermal and chemical resistance. However, the solid nickel and nickel-plated cones have the additional advantage of being more resistant to matrix effects, corrosion, and sample deposition compared to those with a solid copper base. Since nickel runs hotter than solid copper, it is less efficient at heat transfer compared to copper. This allows nickel to stay cleaner longer than solid copper cones, providing extended operating times between cleanings, along with more stable signals and reduced background. A nickel-plated base is recommended when samples have a total acid concentration exceeding 5%. This nickel coating enhances the chemical resistance of the bare copper while preserving the heat transfer properties of the copper base. Some instruments need a cone with a copper base to keep a lower temperature, or an optional skimmer mounting base can be used, as in an Agilent ICP-MS. If a cone gets too hot, it can degrade quickly, especially at the orifice, which affects sensitivity and signal stability. Glass Expansion's proprietary nickel plating process enables us to uphold the highest standards of precision, quality, and reliability for these popular nickel-plated cones. And now let's move on to platinum cones. Platinum is the most durable and longest-lasting choice, but it also has the highest price. Just like with nickel cones, you have several material combinations to choose from. A platinum tip with a copper base, a platinum tip with a nickel-plated copper base, and a platinum tip with a solid nickel base. These options are designed to balance heat transfer and chemical resistance. As a material, platinum offers excellent resistance to chemicals, the highest resistance to matrix effects, corrosion, and sample buildup. Common applications that require platinum cones include high matrix samples, high total dissolved solids or salts, aggressive acids like hydrofluoric acid, especially when total acid concentrations exceed 5%, volatile organic solvents, and applications demanding the lowest detection limits. Platinum has the least efficient heat transfer compared to copper and nickel, which means the platinum tip runs hotter than both copper and nickel. The advantage of having a hotter platinum tip is that it generally stays cleaner longer than nickel-tipped cones. Let's look at some of the unique features and benefits of platinum cones. When using platinum cones in certain ICP-MS models, a brass skimmer base is required, instead of a stainless steel base to help heat transfer in the cone interface area. A sampler cone with a larger diameter platinum tip can extend the cone's lifespan. For some ICP-MS models, a sampler is available with 10, 15, or 18 mm platinum tips. When properly maintained, platinum cones can typically be refurbished 2 to 3 times, significantly extending their operational lifespan compared to other cone options. When a platinum cone can no longer be refurbished, you can recycle it through glass expansion for the platinum reclaim value, which is then credited toward purchasing any other sample introduction consumables. The last cone material we'll cover today is aluminum. Aluminum is similar to copper in terms of both cost and susceptibility to matrix effects, corrosion, and sample deposition. However, aluminum may be the best option if a low-level detection limit for copper, nickel, or platinum is required. We find that aluminum is most commonly used in laser ablation ICP-MS applications. And that brings us to our recap of today's class. Today we learned that you have many options of cone materials to choose from. Selecting the correct cone material to suit your budget, sample matrix, performance goals, and instrument requirements is an important step in optimizing your sample introduction system and results in several benefits, including reduced frequency of maintenance, increased testing efficiency, lower cone replacement costs, and improved analytical performance. Keep in mind, as a cone designer and manufacturer, Glass Expansion has the expertise to manufacture specialty cones, in addition to the OEM design. These specialty cones may not be available from the instrument manufacturer, but are designed to provide improved performance for specific applications. Be sure to contact the sample introduction experts at Glass Expansion for any help choosing the best cones to suit your application needs by scanning the QR code at the end of this presentation and submitting your questions.
Thanks, Plasma Professor, and thanks to everyone for joining us during the second Plasma Pro Tips session. We look forward to seeing you next time, and don't forget to submit your questions to the suggestions box. Until then, happy analyzing!